This is theorem number 8.7. So in this theorem, what the question is asking, that the theorem is saying that if the diagonal of a quadrilateral bisect each other, then it is the parallelogram. If you remember the last theorem 8.6, I'm just for the matter, I once still again reading out that the diagonal of a parallelogram bisect each other. That was our 8.6. So our this 8.7 is the converse of that theorem 8.6. So here we have to prove for a quadrilateral, if the diagonal bisect each other, then it will be a parallelogram. So for that matter, I draw a diagram. You can see the diagram, and in the given part we wrote that ABCD is a quadrilateral in which AC and BD diagonal bisect each other at O. So that therefore, if bisect means, we know all what does bisect mean. Bisect means divide into equal part, right? So if it is bisect, therefore OA and OC will be equal. You can see OA and OC will be equal. And what we have to prove? We have to prove that ABCD is the parallelogram. So in the proof part, what we are seeing in AOB means AOB, this triangle AOB and COD, this triangle. In this two triangle, we can see OA equal to OC, right? And OB equal to OD. Okay, and AOB, AOB means this angle AOB, and DOC means this angle. Okay, they're vertically opposite angle. We can see easily, right? So they are equal. Vertically opposite angle are equal. So we can see in these two triangle, how many things are equal? Two sides are equal and an angle is equal, right? Therefore, the two what do you call triangle are congruent. By which congruency rule? SAA, side congruency rule. So if it is congruent, we can write, then we can write angle ODC, angle ODC, and OBA equal to angle OBA. You can see which is angle ODC. Angle ODC means ODC, this angle, and angle OBC. They are equal by CPCT rule, right? By CPCT, by CPCT. Fine. So we can see, look, in this one, when these two angles are equal, when AB and DC are two lines and BD is transversal, then these two angles are equal, right? We can prove these two angles are equal. Then what we can prove? We can say that AB and DC are parallel because this is the alternative interior angle, right? But these are alternative interior angle which form when transversal BD intersect AB and DC at B and D respectively. Okay, so when BD intersect AB at B and DC at D, then only these two angles are become equal. Okay, so we can say therefore AB parallel to DC. AB parallel to DC. Okay. Similarly, we can prove. Similarly, if we take the other angle, like if you take this angle and this angle and this angle. Oh, sorry. If we take these two triangle AOD and BOC, we can similarly prove the AD parallel to BC. Okay. Similarly, we can prove that BC parallel to AD. Okay. Hence proof. Okay. Any doubt regarding this question? So simple. You have to just take this two triangle and you have to compare their given size and angle and then the reciprocity rule. Okay, fine. Then I'm moving towards the next question. I mean next theorem, last theorem, not last theorem, but almost last theorem. Okay, so our theorem, this theorem is this theorem 8.8. 8.8. This theorem is saying that a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. A quadrilateral is a parallelogram if pair of opposite side is equal and parallel. That we have to prove. So what is given? It is given a quadrilateral, a quadrilateral, a quadrilateral, or sorry, write down ABCD is a quadrilateral. ABCD is a quadrilateral in which AB equal to DC and AB parallel to DC. That is given that in a quadrilateral, if pair of opposite side is equal and parallel, then it is a parallelogram. What we have to prove? We have to prove ABCD is a parallelogram. ABCD is a parallelogram. So here we need one construction. Okay. So before that we'll write cons. What construction? Just very simple. Join B D diagonal. Join BD. That is the only. This is the construction. Why construction? Because look, here given only ABCD is a quadrilateral. If it's AB and BC is parallel and equal, then only we have to prove it is a parallelogram. So BD, we we draw the BD line for our um, like proof purpose. Okay. Now let's compare these two triangles. In triangle in triangle ABD in triangle ABD and triangle BCD in triangle ABD and BCD, AB equal to DC. AB equal to DC. Okay. Then angle angle ABD angle ABD. Okay, ABD equal to BDC equal to angle BDC. Can anyone please tell me why? Showing here ABD and BDC, this red color one. Why? Because look, AB and DC already parallel given in the given part. Okay, and BD transversal, so alternative interior angle. Okay, so we can write as AB parallel to DC and BD transversal. BD transversal. So therefore, alternative interior angles. Alternative interior angles. Okay. And AB equal to DC was given. So we'll write given. Then we can write BD equal to BD because this is a common side. Common sides. Fine. So we already proved that not proof, we already think about this one. ABD and BCD in these two triangle, we can see this one AB equal to DC, then ABD, this red color angle, and BDC, this red color angle are equal, and BD equal to equal. Therefore, we can write therefore triangle triangle ABD and triangle BCD both are both are congruent by SAS congruence proof. Okay, so if they are equal, if they are congruent, then you can see the green color triangle, green color angle ADB and DBC. This green color two both also equal. Okay, therefore then angle ADC ADB sorry triangle ADB equal to triangle DBC. Okay, triangle ADB equal to DBC by CPCT. Then I'm moving little down this. Then if these two angles are equal, okay, understood. You can see AD and BC are two lines where BD act as a transversal and these green colored two angles are equal. Just like the previous theorem. So we can prove AD equal to BC. Okay, so we'll write this. We'll write this one here. But these are alternative interangles which form by transversal BD intersect AD and BC at DB. Respectively. Again, I'm saying this BD transversal. Okay, I did not ask again. Those you are not listening. Yugoni, Jikati, are not you listening? Am I asked the roll number? So where I was saying that yeah, that this BD diagonal intersect AD at D and BC at B, and these green color angle are equal. Therefore, we can say AD parallel to BC. Okay, that means AD parallel to BC. So what we can see in ABCD quadrilateral, we can see AB parallel to DC, from where it was given that AB parallel to DC, and we proved AD parallel to BC. We just proved the second one. AD parallel to BC we just proved. So we can prove therefore ABCD is a parallelogram. Is the parallelogram. Okay. So this is the proof of this last, or not last, there is another two theorem, but that will be done after this exercise 8.1. So that was the theorem. Okay, after that we'll discuss exercise 8.1. We'll discuss exercise 8.1. Okay, up to in this theorem, up to this, if anyone have any doubt regarding this theorem, you can ask me now. If anyone having any doubt, you can ask now. Okay, let's see any doubt is there or not. I did not ask roll number. Okay, I asked if you're having any doubt or not. If you're having doubt, please ask me. Otherwise, I'll wait another 1 minute only. Then only I start the. It's okay. I'm starting the exercise problem. If you're having doubt, you can ask me later. So in the exercise 8.1, we can see that first question is given. The angles of a quadrilateral are in ratio 3 is to 5 is to 9 is to 30. Okay, this is the question. That the triangle, the angle of in a quadrilateral in ratio 3 is to 5 is to 9 is to 30. Find all the angles. So how to do? We know only one properties of a quadrilateral about the angle. The sum of all the angles is 360 degree, right? So using that only we can do. So how to do? We'll do like this. Let the angles of the quadrilateral are 3k, 5k, 9k, 30k. Whenever ratio is given, just this is the way we used to do, right? So you have to write in bracket where k not equal to 0. K not equal to 0. Just to for mention, k not equal to 0. Then, as per question, we know that sum of all the angles of a quadrilateral is 360, right? So we can write 3k plus 5k plus 9k plus 13k is equal to 360 degree. 360 degree. Then, now the only simplification, 3k plus 5k, 8k, 8, 9, 17, 17, 30k. So it is 30k equal to 360 degree. Okay, so you can find k equal to, we will find that 360 divided by 30. Ashwini, why you are so late? In probably the last class also you missed, so I guess. Why are you so late? Okay, so this answer will be 360, it will be 12, I guess. 3 into 12, yeah. So k value we got 12. Okay. uh, so the angles, just now we have to put the values. The angles of the quadrilateral are, first angle will be like 3 into 12 degree, right? 3 into 12 degrees, so it will be 36 degree. Then comma 5 into 5 into 12 degree, which will be equal to 60 degree. Then 9 into 12 degree, which is equal to 108 degree. Then 13 into 12 degree, which is equal to 156. These are the these are the angles. Okay, this is the so easy question. Next, move on to the next question. Next question is saying that the diagonals of a parallelogram are equal, show that is the rectangle. Sorry, yeah, rectangle. So this is our what kind of proof? This is a proof type. So we have to draw the diagram. Let's wait for 1 minute. The diagonals of a parallelogram are equal. We have to prove this is a rectangle. So for this we have to draw. Wait for a minute. I'm drawing the diagram. Okay, this is the diagram. Okay, you can see the diagonals of a parallelogram. You can see one parallelogram is there, is equal. If it is equal, then it is a rectangle. This is we have to show. So Okay, wait for 1 minute. Sorry, this is the correct diagram. Sorry for that. This is the correct diagram. Okay, so what is the given? Let me write what is the given part. Given is ABCD is a parallelogram. In ABCD parallelogram, AC equal to AC equal to BD, because it's saying that they are equal, right? Then AC equal to BD. Then to prove, what do you have to prove? To prove we have to prove that ABCD is a rectangle. ABCD is a rectangle. Okay. Then proof. For proof, we'll take this triangle. In I will not allow anyone now. Pentenlo deny. Just hold on a minute. Okay, so wait. In ABC triangle, in triangle ABC and triangle DCB. Okay, you can see these two triangle ABC, this triangle, okay, and triangle DBC. This two triangle will take, and triangle DBC. We'll consider this two triangle. In this two triangle, we can write AB equal to DC. Okay, AB equal to DC because opposite side of parallelogram, they are opposite sides of parallelogram. Okay, opposite side of parallelogram. Then AC equal to BD because it is given the two diagonals equal. So AC equal to BD. Okay, write down given. Then what can be equal? We can say we can say both. Yeah, we can say this BC is common side. We can write like BC equal to, sorry, BC equal to CB, common side, sorry, common side. Okay, so we can say therefore therefore ABC congruent to ABC ABC congruent to DCB or DBC, you can say. Better to write DCB. DCB. Same triangle, DCB. Better write DCB. Okay, by which rule? By SSS rule. By SSS congruency. Okay. Now, if these two triangles are equal, we can write this thing. Then angle angle ABC angle ABC equal to angle DCB. Okay. Why? Look, angle ABC, this angle, and angle DCB, these two angle by CPCT. By CPCT. Okay, fine. Now, can anyone tell me what is the sum of these two triangle? Sorry, these two angle. But we have, anyone can tell me what is the sum of them? A, B, C, and DCB. What is the sum of them? Anyone? Tell me what is the sum of that? I'm still saying that I did not ask the roll numbers. Those who are giving, I don't know what is the reason. I'm asking that what is the sum of these two, ABC and DCB angle? What is the sum? Fast, please let me know. What is the sum of, not 360-degree? Check only what is saying. Is saying that ABCD is a parallelogram, right? That means AB and DC are parallel, right? So what kind of angle they are? Interior angle on the same side of transversal, right? So sum of these two will be 180-degree. Sum of these two will be 180-degree. Bracket write down as AB parallel to DC and BC transversal. So alternative interior angles. Alternative interior angles. Then, so we have to mark this one. We will mark this one as 1 and we'll mark this as 2. Okay. From 1 and 2, from 1 we can see ABC equal to DCB, and from 2 we can see ABC plus DCB equal to 180-degree. From 1 and 2, if you replace, we'll get ABC equal to 90-degree. Their sum is 180 and they are equal. So from 1 and 2, ABC equal to 180 divided by 2, which is equal to 90 degree. So in a parallelogram, if one angle is 90, that means this is a rectangle, right? We know a parallelogram having angle 90 degree is rectangle. Okay, so therefore therefore ABCD is a rectangle. ABCD is a rectangle. Okay, one thing, look, in exam, if you don't want to write this one, if you don't want to write this, we know this thing is okay. Okay, after this you can write ABCD is a rectangle. Okay, just for your information, I'm writing like this because this kind of question will hold 3 marks. So like, hence proof, hence. Okay, now the things all of you are waiting for, write down your roll numbers. I'll take your roll numbers now. Those who are leaving, I will not count your roll number. Jekote, 31 last year. My class is not still finished. Okay, so those who are, I mean, like leaving the class, I'll make you absent. Mm, Many of you, I guess, still missing. Please write down your roll numbers. Many of you, I think, just muted or something, putting your phone somewhere. Many of you just put your phone somewhere and you're just roaming around, right? If you're leaving, then you're absent. Those who are leaving, I'm making you absent. Okay, fine. Next, last question for today. That is question number three. Question number three is saying, show that if the diagonals of a quadrilateral bisect each other, then bisect each other at right angle. Sorry, bisect each other at right angle. Then it is a rhombus. So bisect means, at right angles means it is making a right angle 90 degree, right? So okay, let's start. um, in AOB, in triangle AOB and triangle AOD. Okay, look, what work we have to do? We will first prove ABCD is a parallelogram. Okay, and we know in a parallelogram, if all sides are equal, then it will be a rhombus. Sorry, yeah, rhombus. We know in parallelogram, if all sides are equal, then it is a rhombus, right? Then, in triangle AOB and AOD, let's see what angles are these. We can say AOB. We can say, yeah, we can write OB. Oh, sorry. First, we have to write something. In ABCD, in given part, I must start with given part. In ABCD quadrilateral, in ABCD quadrilateral, diagonal AC and BD bisect at O and bracket 90 degree. Okay, at 90 degree at O, right? So bisect means OA equal to OC and OB equal to OD. Okay, they bisected, so OA equal to OC and OB equal to OD. Okay, then And you can, just for information, I'm writing angle AOB equal to 90 degree. AOB equal to 90 degree. AOB 90 degree means all angles are 90 degree. Okay, that I'm not writing. We have to prove ABCD is the rhombus. ABCD is the rhombus. Okay. Now no construction is there. Let's start. So OB equal to OD. We can see OB equal to OD in this two triangle. We can see OB equal to OD. Right. Given and OA equal to AO. Right. Because these are common sides. They are common sides. Okay. So this is write down. This is given. This is common side. Okay. In the middle, put the angle. Which angle? Angle AOB. Angle AOB equal to angle AOD. Angle AOB, this angle AOD, these two angles are 90 degree, right? Both, you can write both 90, both 90 degree. They are equal. Okay. So in these two triangle, we can see two sides, one angle are equal. Therefore, they are, we can say, they are congruent. AOB and they are congruent. Congruency rule is SAS by SAS. Okay. Now from here what we can write? We can write then AB equal to AD, right? AB equal to AD by CPCT, by CPCT. Okay. These two triangle AOB, AOB and AOD. These two triangle we can prove that they are congruent, and after that we can prove that AB equal to AD, right? By CPCT. Similarly, we can prove if you took any two adjacent triangle, we can prove AD equal to DC, DC equal to BC, and BC equal to BA. Okay, we can prove AD equal to DC, comma DC equal to BC, comma BC equal to AB. We can prove. Okay, so from 1 and mark this one 2. From 1 and 2 we can write what? Here we prove AB equal to AD, and from 2 we can see we can prove AD equal to DC, same DC equal to BC, and BC equal to AB. So from 1 and 2 we can not write down just this: AB equal to DC, AB, sorry, AB equal to, right, DC, BC, AB equal to BC equal to CD equal to DA. Okay, AB, BC, DA, DC, CD and DA from these two. Okay, now what we can say, look, in ABCD quadrilateral we can say that opposite sides are equal. Now in ABCD quadrilateral we see AB equal to DC and AD equal to BC. Okay, look, because all are equal. Okay, so we can write AB equal to DC, DC means CD, AB equal to DC we can write, and AD, look, DA and BC also equal, so AD equal to BC. That means you can see, we in one quadrilateral, if opposite sides are equal, then we can say it is a parallelogram, right? Therefore, so after that we can write, therefore ABCD is a parallelogram. ABCD is a parallelogram. Okay, so mark this point as 3. Which one 3? When all are equal. And mark this parallelogram part 4. Okay, now what we can say, from 3 and 4 we can say ABCD is a rhombus, because we know that in a parallelogram if all sides are equal it will be a rhombus. Okay, we can write from 3 and 4 we can write ABCD is a rhombus. Okay, this is a little bit tricky. Okay, after that, after ABCD, AB equal to BC equal to CD, I mean in a quadrilateral all sides are equal, we can say directly it is a rhombus. Okay, because our square is also a rhombus, special kind of rhombus. But if we prove in the middle it is a parallelogram, it will be much more easier to say. Okay, so this is our